I'm Brian Deska. I'm the founder of Deska. Deska is a full service structural engineering and structural contractor, and we're located in Alexandria, Virginia. We essentially diagnose a lot of the structural issues that you guys flag as symptoms in a lot of your reports, and we end up designing the repairs as well as performing the structural repairs as well. I put together some interesting symptoms and issues that we encounter, along with some case studies that will hopefully help you identify some issues as well as educate your customers on potential repairs and cautionary tales. That's me. Essentially, we diagnose, design, and repair structural issues. We just have some licenses and specialty certifications that we'll breeze through here. So to start off, we have our static forces, which in the top left corner, you see tension, essentially pulling apart of a member. In the top right corner, compression, the axial compression of a member. Torsional forces, the twisting of a member. Shear forces, which is essentially the tangential force on a member. And then at the bottom there, we have essentially a beam, which is the bending effect, and where one side of the beam is in compression and the other side is in tension. It's typically in most homes, the beam is upside down as opposed to this particular picture here. So we'll start with some foundation wall issues. We'll start with lateral movement of foundations. And we'll go into we'll just start with some cracking to start. We see horizontal cracks, vertical cracks that you see there in the corner, as well as step cracks and shear cracks down in the lower left corner. And foundations often have water intrusion as well. For these stair step cracks, like in these top two pictures here, just to help you kind of identify what may be going on when you see these. Typically, we look at the overall trend of the crack. So it's a stair step crack, so it's running horizontally and vertically. However, the overall trend of the crack is actually more like a diagonal crack, and that's essentially the slope of the crack. And usually, what that tells us is that the low side of the crack here is the side that's settling. It's a little bit intuitive. If the high side of the crack were to be settling, then the crack probably wouldn't have opened as it did here. The same thing on the other side here. You see the diagonal slope of the crack, and essentially the low side of that slope is the side that is settling. The crack in the lower picture here, while it does have one stair step to it, it is mostly a horizontal crack, and that's from the lateral bowing of a foundation wall. So here are some other examples of this. It's typically due to usually water, and this is one of the main reasons why it's so important to keep water away from the house with downspouts, French drains, and grading. When that soil on the exterior of the home saturates into that soil, the expansive force of that soil puts an immense amount of pressure on these walls, and especially in a lot of these older CMU block walls, they're not reinforced with steel, so they end up bowing in. And the one on the picture on the right is a little bit of a essentially a pretty terrible case there. The one on the left is probably a little bit more common. And that's typically what you see when you see all of that stair stepping. That's typically closer to the corners of the foundation walls, which we'll get into here in a little bit. So when you see cracks like these at the corners, sometimes you can only see a few inches of them, and you may not be able to see anything in the basement, especially if it's a finished basement. But they're typically due to the wall, in both cases here on the left, bowing inward. So not the wall with the crack in it, but actually the adjacent wall. And that's typically caused by if you take a finished basement like this and you can see these little cracks on both sides of the front corners. If you were to remove that drywall on the inside, oftentimes this is approximately what you would see. And if you were inside of the basement staring at the wall, that's essentially a textbook case of what you would see. The long horizontal crack of essentially the hinge of the wall bowing inward. And then as the wall meets the corners, it's essentially being braced by the perpendicular walls, in this case, the left and the right foundation walls. And because of that, because of the moment there, there's essentially a torsional effect, and there's a moment there, and you get this stair step cracking that looks like this. So if you're ever looking at a finished basement, but you just see these little cracks on the front corners, there might be a little bit more to see behind the drywall. So just something to keep an eye out for. Here's another example of a horizontal crack, although it's on the exterior and it's above grade. But essentially, when that wall bows in laterally, the it has to essentially pivot somewhere else as well, and that often happens above the foundation wall or at the top of the foundation wall, and it opens up in a similar manner as the wall does at mid height. Here's an example where we have a large tree that has grown right next to a foundation wall. And if we look closer here at the top of this foundation wall, we can see that same horizontal crack there. And that's essentially from the tree being way too close to the wall and growing right into the wall. On the inside of the wall here, you can see that the wall has cracked in many different ways, including down here at the bottom right. The wall has actually sheared in. And when I say sheared in, I mean the blocks have essentially slid on top of one another. And that's what we're seeing there. And that's a very serious issue. In terms of solutions for bowing walls, ideally carbon fiber. Carbon fiber is an excellent solution. However, it only works, it's only very strong in tension. So if the wall is bowing inward, carbon fiber straps can be applied, assuming the wall is bowing in typically about 1.5 inches or less. If the wall is shearing, carbon fiber straps can no longer be used, though. So you have to be very careful. The carbon fiber straps have very little strength in tension, or I'm sorry, in shear. They're only strong against bowing and in tension. And these straps essentially they get epoxied to the wall and they get anchored at the bottom and the top. These particular straps, these are ICC certified. In most, well, at least in the municipalities that we work within, they all require an ICC certification for any structural repair, and these are typically the ones that we'll use. Here's an example of the carbon fiber straps. Not the prettiest looking, however, you can actually paint over them. They're only about 1/8 of an inch thick, so you can paint over them. They're barely visible after that, and you can also finish the basement. No one will ever know they're there. It is a permanent solution. Typically, companies will offer a lifetime warranty with them. It essentially is warranted for the life of the substrate, in this case, CMU block wall. And you'll notice in this picture here that all of these mortar joints have been retuck pointed as well. So when these straps are installed, the mortar joints must be retuck pointed or epoxied as well. Otherwise, there's actually a concern that if the soil on the outside shrinks, the wall could actually bow backward, and that would actually put the straps in compression, which they are not allowed to be in. They are very weak in compression, and you could actually damage the straps. So these mortar joints must be retuck pointed, so it essentially forces the straps to be used in tension.
Hey Brian.
The
Brian,
the
have you ever seen a carbon strap fail?
Yes, I have. Yep. Typically, where they fail actually is in the actual substrate itself. If the substrate is not prepared properly, you have to grind the coating off, the paint coating or whatever stucco coating, whatever happens to be there, and then it needs to be vacuumed out. And the top and bottom anchors also need to be installed. A lot of companies for years installed these straps without the top and bottom anchors. And so those are a lot of the ones that we see failing. The these are fortress stabilization systems, carbon fiber straps here, and they're required to have the top and bottom anchors.
Hey, Brian,
Yes,
is this okay to interrupt you like this? Or
sure.
okay. What's the typical spacing like for these straps?
So the typical spacing is 2 feet from the corners, and then every 4 feet is for the intermediate spacing. But that varies depending on height of the wall, the height of the fill behind the wall, as well as the thickness of the wall as well. And these straps can be installed on concrete walls, they can be installed on block walls, and they can be installed on brick masonry walls as well. The picture at the bottom here, that's an example of what we call a shear pin. Essentially, it's installing rebar within a hollow block wall and filling the wall with grout after the wall has been built. Many walls built today, they will just have the steel reinforcement already in them. And you can actually mix and match these two solutions. You can actually shear pin a wall as well as install carbon fiber on it as well. Here's another type of solution. We call these steel struts or steel beams or power bracing. There's numerous different names for them. Whalers, some companies call them. These are essentially for walls that have sheared or have bowed in more than about an inch and a half or so. Um, these are also a permanent solution. They they have footings down below the slab that they are essentially poured around, as well as they have, in this case, there's a steel angle that attaches to all the floor joists above. And then the space in between the steel beam and the wall is grouted because the wall is typically bowed inward in some way. The steel beam is perfectly straight. So at usually closer to the top and the bottom, there's a space, could be a quarter inch, could be 2 inches, could be closer to 3 inches. That gets filled with a grout so that the steel beam provides an evenly distributed load on the wall. So here's another example of a wall that is essentially bowed inward along with some shearing as well. You'll notice this, we have some stair step cracking here, and that's at the corner, which is pretty common. The top there and the bottom. The wall has not only bowed inward laterally on, say, the y-axis, but it's also bowed inward laterally on the, say, the x-axis, which is why we see that crack in the top right corner. And then you can see in the bottom left corner, there's some shearing there. And then the bottom right corner, when a level is held plumb on the wall, you can really see how bad that wall is. This wall in particular was actually bowed in a little bit more than 3 inches. Typically, that would put you in the replacement category. However, this is actually the same wall here, and we were able to essentially temporarily brace it and actually push the wall back and install some steel struts. You'll notice we have this vertical bracing here that essentially supports the floor above since the wall was compromised at that time. And then in the top right here, you'll see we have some lateral bracing as well. And they essentially should be installed at about the same time. When you install this vertical bracing, you're actually in some ways doing a disservice to the wall because when you have a lot of weight pushing downward vertically on that wall, it actually makes the wall stronger and less likely to bow inwards from a lateral force. So when you temporarily brace the structure above like that, all of a sudden you've taken the load off of the wall and then it actually weakens the wall. So you really need to install some lateral bracing as well, depending on how long it's going to be in that situation. Um, so down in the lower right corner, that's actually the finished product there. Typically, as I said, the wall would be a replacement. However, in this case, we actually excavated on the outside. The owner wanted to put in an egress. And we were able to actually push the wall back to approximately straight and install the steel struts there. So the owner kind of took I guess, turned it into an improvement. Instead of just replacing the wall with another wall, he actually put in an egress well as well to increase some value to the home.
Hey, Brian,
Yep.
is there a rusting concern where the beams touch the wall or in the ground there or anything?
No, so the beams are all painted and then they're grouted as well. Um, and it's in essentially a conditioned environment. There are clear cover requirements. So at all areas where this concrete goes into, where the beam goes into the concrete, there are clear cover requirements. So it has to be surrounded by typically about 3 inches of concrete. That's the minimum is about two, but we always over design everything. Essentially, we use 3 inches of concrete typically to ensure that no water is getting to the steel beams. And in this particular case, a drainage system was actually installed at the same time with a vapor barrier to protect the beams as well. So the short answer is yes, but the proper precautions need to be taken. So here's an example of a wall that had collapsed, and this was because a waterproofing company went to put in an interior drainage system. You'll notice along the bottom there that someone had trenched out the floor, and the slab on most of these foundations is not meant to laterally brace the wall. However, the wall is also not meant to bow inward either. And so what ends up happening is when some of these walls bow inward, the slab ends up by default laterally bracing the wall essentially by accident. And usually the water issues go along with the lateral stresses on the wall. So a lot of times waterproofing companies will go out to install a drainage system, and the same reason why they're having a water issue is the same reason why the wall is cracking. And if they don't appropriately address that, and they're not aware that there's an issue, they'll remove the slab and not temporarily brace the wall, and then they'll get a cave in like this. And that's essentially has to be replaced at that point. So another method of laterally bracing a wall is these are called wall anchors. These essentially they have a wall anchor plate all the way on the left, and then they have an earth plate all the way to the right in the ground, and then they're tied together with an anchor rod, and that anchor nut on the inside of the basement is essentially torqued to a particular uh, amount of torque. Usually it's 85 to 100 foot-pounds of torque, but it varies. And essentially it does something similar to the straps or to the steel struts. We generally prefer to use the straps or the struts. We prefer not to anchor the wall with the soil outside, especially, the soil expands and contracts. So we prefer to anchor to something that we know is not going to move as opposed to something like soil. The one upside to a solution like this is if you tighten it on a seasonal basis when the ground is drier, you can potentially straighten the wall, but I wouldn't count on it, but it is a possibility. Um, we typically would use these only when there's certain circumstances that this is really the only option. So here's an example of a wall bowing inward here, and you can see that you have your long horizontal crack near mid height, and then it stair steps out the corner there. Here's an example of an areaway with the retaining walls that you can see are leaking quite a bit. That essentially is a symptom of a failed exterior drain tile. So that water is building up there, and that pressure is pushing inward on these walls. Essentially, really the only way to address the bowing of the wall in this case would really just be like a wall anchor, or several wall anchors, I should say. Um, but they're very visible. They don't look very good. You're still not addressing the problem of the drainage issue. So in this case, really the best way to resolve it is just to replace the wall. This wall in particular was a double width brick wall. So there's really not a way you can't put shear pins inside of it. You can't use carbon fiber straps because there's nothing to attach the top anchor to. Um, and then, if you wanted to use like steel struts, they're going to sit in too far and you're not going to have enough clearance in your staircase any longer, and it would become a code issue. So in this case, we replaced it with a reinforced block wall, and you can see that we also installed a railing that meets the code, whereas the old railing, while it may have met the code with that chicken wire on it, but that's obviously not ideal.
Hey, Brian,
Yes.
we're all glaring at the missing downspout elbow there. But I had a question for you on the last slide about the wall bracing. Will those wall braces work if only, they're only touching a half dozen blocks there? Will they really stop the movement?
So it varies on the thickness of the wall. There's different spacing requirements, and it really varies on the amount of fill on the outside and the thickness of the wall.
Okay.
Yeah, the downspout here, I think it just wasn't installed yet. It looks like the the topsoil was freshly placed there with and seeded. Here's an example of a wall that had caved in completely. It was about 26 feet of wall actually, and most of the side of the home. And this it particularly was in North Arlington, and the wall was reinforced but had many cold joints in it, and there were several drainage issues on the outside. And fortunately, this homeowner actually had that cripple wall installed there. You can see in the top right corner at some point to support a staircase, and that really is probably what saved the two-story home above it. Um, in this particular case, we couldn't even get in there to properly evaluate it. We had because it was so dangerous, we had to install temporary bracing first, then evaluate what was going on, and then design a wall replacement here. Which, if you look at the bottom right corner, you can see that's actually the new wall there. Here's another example of a wall failure, and someone had installed some pretty crafty lateral bracing there in the top left corner as a temporary repair. And this wall again is beyond repairing, beyond stabilizing. Replacement was required, and you can see that at the bottom right corner there, where the unpainted blocks are. Here's another example of a wall failure. This wall has really just bowed in too far, and require replacement. And in this case, the vertical bracing only there is really not doing the wall any favors at the moment. And it has a quite a brick facade above this as well that's just very heavy. And so here's an example of a wall replacement, where you have a block wall along with a brick facade above it. And where that becomes very precarious is in the temporary bracing. And you can see here in the top left corner, there's some vertical bracing of the floor above. The problem is that there's an exterior brick facade here as well, which you can see in the lower left picture here, as well as there's a block wall above it as well. So the construction of this home has a brick facade as well as a 4-inch thick brick exterior wall, both of which are very, very heavy. And by just supporting the floor joists above or the floor above, you're not going to be supporting that very heavy exterior wall. So these beams had to be designed and installed. We call these needle beams. They essentially go through the wall and the facade, and they support both above it. And you can see in the lower left picture, that's where the wall's been removed. And in the lower right, the wall's being rebuilt below the needle beams. And here it is continued with the essentially wall replacement here on the right and the lower right, and a primed wall you have as the new wall. The so this is an example of significant erosion at the corner of a basement foundation. You can see there's what appears to be quite a void there, and you can see the footing. So, all footings are supposed to go down to a frost depth, which means the bottom of that footing needs to be below a particular depth in the ground. And in our particular area, it's 24 to 30 inches. In some areas in Minnesota, it might be 6 feet deep because it gets so cold. In other areas, maybe in Florida, there's no frost depth at all. It essentially needs to be below the frost line, which is when the ground freezes, it can cause the structure to heave when the ground freezes and expands. And so in this particular case, not only is the bottom of the footing visible, so it's obviously not below the 24-inch frost depth, but below the footing is undermined, and you can see that that measuring tape goes underneath about looks like 16 inches or so, and that's a very, very serious issue. And where this issue was located, it was very difficult to get to. So, if you're ever inspecting a home that's on a cliff or near a steep slope, and maybe there's some areas that are very difficult to access, I would try your darndest to get to those areas and at least take a peek just to give it a sanity check and make sure you don't see anything too crazy like this.
Is that North Arlington?
That is, yep.
Uh-huh. I think I
Now
know that
this,
house.
what's that?
I think I know that house.
So on the same house here, on the other side of this foundation wall, we have a slab, and there's some minor cracking in the slab, and usually that's no big deal. Most slabs are not structural, but occasionally they are. In this particular case, the slab is not structural, but when we put a laser level on that slab, we actually found that it was sloping about 2 inches towards that same eroded area. And then there turned out to be a void below that slab as well. So not only has the soil eroded from the bottom of the footing, the support footing here, but it's also causing issues inside as well. So if there's one theme that I guess I would like to express to everyone, it's that symptoms don't usually happen in a vacuum. Usually, where you see one symptom, there's always a reason for it. Whether the reason is serious or not, that's a different question. But there's always a reason for it, and oftentimes there's other cracks or other symptoms that fall into that same pattern or are being caused by that same culprit. And so, okay, so here's an example of a tree that had fallen nearby a house. Luckily, it just missed the home, didn't cause any serious damage to the superstructure of the home. However, you can see that the root structure of the tree was pulled out of the ground, and you can see that there's some potential undermining along the footing here, along this garage foundation. And in this particular case, there was no symptoms of any issues, but it's something to keep an eye on that when you have something like this happen. If a lot of the earth is pulled out from below the footing, you could have an issue. Luckily, the owner of this home didn't, but it was definitely a close call. Here's an example of someone who excavated below the bottom plane of the footing, which is a big no-no. Essentially, if you can see in the top left corner where they dug looks like a couple feet below the bottom of the footing, and that's just dirt there. So if there's a lot of rain and water begins to come through there and wash out some of that soil, there's not much that's going to be holding up that foundation wall any longer. Um, so this is an example of what we call traditional underpinning, where essentially you excavate below and you install a concrete footing below. Assuming there's no settlement, no damage caused, or no movement, you can essentially carefully, with temporary bracing and in a sequenced phasing approach, you can actually excavate and install a new footing below. So some other examples, for instance, like that house in Arlington with the serious undermining. Really, the only solution for that is what we call helical piers, and that's on the right side here. They're essentially like giant screws that get screwed into the ground, and the amount of torque that they're screwed into the ground with is directly proportionate to the capacity of them. The picture on the left here, those are called push piers. They're also a deep foundation, however, they just get hydraulically pushed into the ground. They both function pretty similarly. They essentially go deeper until they reach a much stronger strata of soil that can support the loads above. The main difference between the two here is that the push piers rely on the weight of the structure to be installed, whereas the helical piers are installed separately from the structure. So that house in Arlington, where it's essentially floating, you can only you could only stabilize that with helical piers because you would not want to apply the loads to the foundation with the push pier, as it would be bouncing the structure up and down, and you'd probably have some major problems. So here's an example of helical pier installations. Essentially, a machine, in this case a mini excavator, is screwing this giant screw into the ground. The bottom left corner, once the screw is installed, the high capacity rim is installed and jacked to a capacity that's essentially decided by an engineer. And then the lower right picture is essentially several brackets attached to the footing to properly support it, and essentially take the load off of the shallow soil and transfer that load down 20, 30, 40 feet. Just depends on the capacity of the soil. Here's an example of chimneys. They're very heavy. They tend to settle. In this case, when they settle, they crack, and they also tend to pull away from the house as well. You can see the stair step cracking there, as well as you can see the chimney has pulled away. In this particular case, 2 helical piers were installed, and then a custom fabricated bracket was installed as well that actually tied into the structure of the home to essentially secure it, to prevent it. So you essentially are resolving the settlement issue with the helical piers, and you're ensuring that it doesn't lean outward any longer by tying it back into the structure of the home. Some issues that you guys may see: expanded lintels. When these structural steel lintels corrode, they tend to expand, and then they begin to damage the facade. And just to back up on what a steel lintel is, so when you have a brick facade or a brick wall, the bricks all support the bricks above them. Then all of a sudden, when you have an opening in the wall or a hole cut in the wall, there's nothing to support those bricks anymore. So you have to install a header of some sort. And oftentimes it's a steel angle that looks like these. And usually that steel angle will bear on each side of that opening 4 to 6 inches. But when the moisture gets to the steel, especially when it's near the exterior like this, the steel corrodes, it expands, and that expansive force is very, very powerful and causes a lot of damage to the facades. And you'll see it will expand these mortar joints. It will oftentimes lift the entire facade, and if it can't lift the facade because there's too much weight above it, it will begin to bow the facade or exterior wall outward because it needs a place to go. The lower picture here is just it's just a facade that's not properly supported and really should have a lintel installed and anchored to the wall there. So an example of what happens when, whether it's lintels or whether it's just the construction and the walls are bowing outward like that, the solution is essentially to install these wall or facade anchors. So in these older homes, these two are both in Washington, D.C. These are not just facades, but they're actually double or triple width brick masonry walls. And when they begin to bow outward, one of the ways to laterally brace that outward movement is with these facade anchors, which you can see they're stars. They can also be square plates. You've probably seen them all over the place there. While they're sometimes just aesthetic, oftentimes they are not just aesthetic and they are actually a structural repair. In terms of cracking in concrete, a newer product that I wanted to kind of make you guys aware of is when you're epoxy injecting a crack in a wall or in a slab, they make these carbon fiber stitches now, and along with epoxy injecting that crack, you can actually install these stitches, and they will actually make that particular crack much stronger than the surrounding concrete. And so companies actually install these, and they provide lifetime warranties on the crack. Now, if the underlying issue that is causing the crack is not resolved, say a settlement issue, these stitches or the epoxy injection will not prevent that issue from getting worse. You generally will just get another crack somewhere else. But the crack that is epoxy injected and stitched will not reopen. It will just crack nearby until that underlying issue is resolved. Here's an example of that, of a crack in a slab that's been epoxy injected and stitched. All right, well, we'll talk about some beams and columns here. Hollis, how am I looking on time? All right, well,
Ryan, it's 12 minutes after 9, and you've got till 9:34.
okay.
So you got what, 12 more minutes?
Okay, I think we'll be
24, 20, 22 more minutes. 22 more minutes.
okay, perfect. All right, so we're going to talk about the span length of beams versus the bending strength. We're going to discuss the essentially issues with people removing columns and settlement related issues, as well as some floor joist and truss issues. This is an example. This is actually in Vienna, Virginia, where it's a brand new home, and the back corner of the house here has some pretty serious settlement. It settled about 2.5 inches or so in only a couple years. You can see here, I mean, usually in the pictures you can't see the sagging effect, but you can see it here. And essentially what happened is that they poured the footing of this column too close to the disturbed soil of the basement. So usually within about 6 feet of a basement, the soil is much softer as it was excavated out and then they backfilled it. And if you put a shallow foundation footing on it, it will typically settle pretty quickly. And this was only a couple years old, and it had already settled 2.5 inches, and it would have probably settled a couple inches more in a couple more years. The solution here is you have to get down below that disturbed soil. In this particular case, temporary bracing had to be installed, which was a little bit tricky because you have a structure below it that is also being braced by the same column. But essentially the column footing needed to be underpinned with a helical pier, and that helical pier needed to go about 10 feet minimum to get down below that disturbed soil until it met its appropriate capacity to support that load above. Here's an example. Obviously, the column has fractured and it's failed. I mean, it could be mortared up, but really it should be replaced. Another issue that we see often is in these two lower pictures. This is in a crawl space, and you have a beam on the top and you have a column below it, and you'll notice that the beam is floating there. And this actually happens more frequently than you would think. But these columns, they settle, and the beam essentially is not supported. And whether the beam has moved with it or not, either way, that beam should be supported. You can only add so many shims and shim it so many times until it makes more sense to actually resolve the actual issue and either install a deep foundation or install an oversized footing to prevent it from continuing to settle. So when we talk about beams, the purpose of a beam is essentially to bridge two supporting members. So if you look where that arrow is pointing, you'll see that you have two supports on each side. And then the purpose of the beam is to support the loads above in between those two, typically columns or foundation walls, could be a lot of different things. And typically the bending stress is what governs a beam when you're designing a beam. You have bending stress, then you also have the shear failure of the beam, which essentially is where the beam fails right above the supports. But pretty much in a residential sense, the failure always occurs due to a bending stress, and that's what causes the beam to sag downward and give that smiling look. The equation to determine the maximum bending moment is down here on the right, and you'll notice it's the uniform load multiplied by the length squared over 8. And the key there is that you'll notice that the length is squared, which essentially means that for every foot, let's say, the span length increases, the maximum bending stresses, they increase exponentially. So an example of this here is you have these two 8-foot spans with a uniform load above, and then all of a sudden you remove the center column, let's say, and all of a sudden you go from having two 8-foot spans to one 16-foot span. So the span length has increased 100%. So you would probably think, well, the stress in the beam would increase 100%. Well, because that equation, the bending moment actually increases 300%. So when you have situations like this here, where you have this nice house here, and you'll notice in the top left here, there's a 2-car garage and there's a column in between. And then all of a sudden, at some point, somebody decided to remove that column and they wanted to just have one big garage door. And you went from having two 8-foot openings to now about a 17-foot opening. And in this particular case, there was only a double 2x12 supporting it, and there was also a splice joint in the middle of it. It's a major no-no. And then also because you remove that center support, you now have increased the loads at each of the corners as well. And then they're having settlement issues at the corners because the footing there was not designed to support those increased loads. So in this particular case, this 2-ply 2x12 was replaced with this. In this case, this is it was a 10-inch, I believe it was W10 by 39 steel beam. So a 10-inch tall beam by about 39 pounds per linear foot. So a very heavy steel beam. And you can see there it is installed. And then in the bottom right corner, the footings at each of the ends needed to be reinforced as well to support those increased loads.
Hey, Brian,
Yes.
have you ever had a situation where you decided not to take on a job?
Absolutely, yes. Did you want to bring up a specific example?
That was a question from Alex. I
Now,
don't
what
know
was
if
this? What is an example of why you decided not to take it on for your company?
Um, Generally liability reasons. Um, Especially if you're getting into, say, duplexes or townhomes where the repair could affect numerous properties. Um, Typically, we prefer to work for one owner, whether it's residential or commercial. When you get numerous tenants or owners involved, it can become pretty precarious and a headache.
Good answer. Thanks.
So here's an example here where someone had installed a 12-foot wide door, and the owner was concerned. He noticed that the molding above the door was sagging downward, and that bothered him a little bit. And so we put a laser level on the wall or the area right above that door, and we were able to measure the distance from the ceiling down at the ends, which in this case was about 16 inches. And then if you compared that to the ceiling down at the center of the door, it was 15 inches or so approximately. So that had sagged down about an inch. We also put a laser level on the floor above, and essentially we're getting about an inch and a half or so of settlement of the floor as well. So all of these signs leading to a sagging issue of the beam above. And so the next step in this case, we had the owner remove some sections of drywall and determine in this case there was just a 2-ply 2x12 here supporting this. It was a 12-foot opening, and if you look on the outside here, it's supporting a floor above, which is also cantilevered, as well as a roof above as well. And the existing beam was only rated for about 30% or so of the actual design load for the home, or I should say the working load for the home. So that needed to be replaced. It was a serious issue, and his door was beginning not to work. And in addition to that, to take it a step farther, one of the sides of that door is actually right over an abandoned window in the foundation. So not only was the beam inappropriately sized by a lot, the column on the one side was not properly supported either. And so the solution, this is actually an ongoing project as we speak, but the solution, we're replacing the beam as well as filling in this section of the foundation, the open section of foundation wall, to have that properly supported. Some floor joist issues
Hey,
here.
Brian.
Yes.
I'm sorry, man. There about that last part. There's a question. So the new beam supports 1100 PLF, but how much safety margin beta did you specify?
So that's the allowable. So that is the actual. Those are the actual. The factors are included there. Those are the allowable capacities of the two beams, or I should say, the existing beam. The allowable strength is 300 pounds per linear foot. The actual requirement is 1,100 pounds per linear foot.
Gotcha. Thank you.
So I'm sure you guys see these floor joist alterations a lot. Some people use saws, some people use drills, and obviously this is not acceptable. There are limits to where you can notch or bore a joist or a beam, depending on the type of beam or the type of joist. Here you have someone installed a P trap. I guess that's a P trap, right? Not an S trap. That would be a P trap. Looks like from our last class here. But
Yes.
yeah, so these obviously are major issues. If it's just one joist, it's not Not catastrophic, of course, as there's many joists, but it is definitely a structural issue and it needs to be repaired. If there are numerous joists notched like this, that can become a very serious issue. In terms of where and how you're allowed to notch or bore a joist, there is the code that has certain requirements on that. This is just an example of a 2x stock joist. Keep in mind if it's an I joist or an LVL, it could vary depending on the specific material and the manufacturer. But this is just a general example for a 2x stock. So just another example here, when you increase a span a little bit, say you have an 8-foot span here and a 2-foot span, and then you remove one of the supports, so now it goes from an 8-foot span to a 10-foot span. The span is only increased by 25% in length, but again, the bending moment, which typically governs, increases by 56%, and that can become very serious. So even if you're only increasing the span length by a foot or two, that can make a huge difference. And on that note, we are big fans of intermediate bracing. So when you have a span, let's say here it's 14 feet, and then you install intermediate bracing, in this case at mid-span, now you have 2 7-foot spans. So you've decreased the span length by 50%, but you have decreased the bending moment or the bending stresses in that beam by 75%. So when floor joists are sagging or a beam is sagging, oftentimes a very effective way to mitigate that is with intermediate support, assuming the application allows that a support can be installed there. So here's an example of some of these crawl space post jacks, people often call them. They should have footings, as well as, if you're getting sagging of the beam in a crawl space, you can install one of these. If the sagging is with the floor joists, you can install these with a beam at midspan. Typically, we recommend these in crawl spaces. You can install them in basements, but most of the time people don't want to add columns to a basement. It just gets in the way and isn't very appealing. Here's an example of, I'm sure you guys have seen many stacked block on supporting beams. The support should really have a mechanical connection, and it should have a footing below. If it's just on the dirt or if it's just on a slab, the slabs usually aren't structural and they can move. So we always recommend a footing. Here's a couple examples of just details of basement columns with footings and crawl space footings with jacks, or in this case, it's a square tubing here. Here's just a brief example of a general span detail of a joist sistering detail. And something to keep in mind is, depending on the application, when you have the defect, depending on where that defect is located on that span, there are different requirements for how long that sister needs to essentially develop on each side of that defect. So if it's near the center, it's going to be longer. If it's near a bearing point or within a couple inches of one of the columns or a bearing wall, then it's typically going to be shorter. But it's not just something that I would recommend a handyman just go and do. I would recommend, at least at a minimum, consulting with an engineer for the appropriate repair.
5 minutes, Brian.
Okay. Here's an example of what we call a flitch plate retrofit. This is an example where you have an inappropriate or an inadequate sized timber beam. Steel plates, or in this case, a steel channel, can be bolted to it to increase the capacity of it. In this case, we call this a flitch plate, where you essentially sandwich the timber beam with steel. Here are some trusses that have been cut. Apparently, the plumbing was more important. But once they started to have some settlement issues, or I should say, some sagging issues relating to it, they changed their minds about that. So trusses, in order for them to be modified or altered, it must be at the direction of a registered design professional, essentially an engineer. That applies for floor trusses, that applies for attic trusses, and that even applies to new construction. If when they're building a home, they crack a truss, an engineer needs to essentially come up with a repair, and needs to sign off on that. Whereas the trusses are generally only inspected at the factory, but once they're out of the factory and they've left that inspection, they any alteration needs to be approved by an engineer. Here's an example of something that we actually see quite a bit of, where someone builds a deck. There's whole communities built like this in some areas. I'm not going to mention any names, but where they installed the ledger board on top of the siding and without flashing as well. And what happens is, one, water gets behind there if there's no flashing, and two, because you have this soft, flexible siding, the ledger board does not get a solid connection to the band board of the home. And what happened, and you're solely relying on these bolts, which are essentially loose, and it's not appropriately supported at all. Water gets behind, rots the band board, rots the interior wall out, causes a lot of damage, typically very slowly. So anytime you see a situation like this, or if you just see there's no flashing, I would recommend putting a moisture meter on the drywall in the interior. We've seen situations where the entire wall has essentially deteriorated, and no one knew about it until after 30 years, they're beginning to see a little bit of mold or a little bit of dark staining on the wall. In this case, the whole deck had to be pulled away from that, temporarily braced and pulled away from the house, the band board replaced, and then the deck pulled back to the house. It's a very expensive repair for what it is, and oftentimes it may be better just to replace the deck depending on the age of it.
Hey, Brian.
Yes.
You talked about trusses a second ago. Do you mention anything about collar ties that have been removed?
That's not typically something we see too often. We don't do a lot of inspections for that. Mostly it's related to some sort of damage. So we have come across that, but that's not usually something that we get into. Usually we don't see damage related to that.
Thanks.
Couple issues here. Voids below slabs. So you'll notice here you have the top landing of an areaway, and you'll notice it looks a little funny around the bottom or on the base of it. And when we stick a measuring tape in, it goes in 4 feet. Essentially, there's quite a void below it. So just maybe something to keep an eye on. Ideally, you'd probably flag it and let the potential owner know, as opposed to them buying the property and them finding out a month later after they peek down there and realize they have a problem. Here's another example: a small hole in a slab. Slab's not structural again in this case, so you probably think no big deal, except for that there's a 9-inch void below the slab. And while it's still not technically a structural issue, again, these symptoms don't usually happen in a vacuum. So there's typically more going on. There's probably a drainage issue here. The solution here, one, is to figure out why it's happening. Usually it's a drainage issue. Make sure that's resolved. And then typically we recommend poly injecting, or you can also you can do what's called mud jacking as well, which is where you essentially inject basically concrete into the void. We prefer poly injecting just because it doesn't weigh as much. Usually the soils below these slabs have already been compromised. They've been wet. They're very soft. And when you inject grout, it's extremely heavy. The concrete is about 150 pounds a cubic foot. and you're adding so much weight to it that oftentimes you'll just get more issues.
So Brian, what I'm gonna do here is ask you the question that everybody's wanting to ask, but I think everybody's afraid to.
Sure.
Yeah, is it footing or is it footer?
It can be either. They're used interchangeably.
I've noticed you actually use them interchangeably. I was corrected when I studied materials and methods of construction. The professor came down on me with both feet if I ever called it a footer. He'd say, "What are you from, West Virginia?"
I'll have to check, some of my books, but I'll tell you, we work with a lot of engineers, and we all use it interchangeably. Whether that's technically correct or not, you may be right about that.